Good morning, I am Dr. Mohamed from Electrical Power Engineering Technology of Bana University, Egypt. I am going to present my paper entitled Parameter Estimation of PV Modules Without Experimental Measurements Using Particle Swarm Optimization Technique. I am going to present the following points. Objective of the work, structure of PV cell, PV model, problem formulation, summary of PSO algorithm, and finally I will present some obtained results followed by a major conclusion. Objectives of the work. In this work, we want to apply the particle swarm optimization technique to estimate the parameters of PV modules based on the available PV datasheet at only 3 points. At short circuit points, open circuit point, and at maximum power point, without conducting any experimental measurements. The basic PV cell consists of the following layers: upper metal conductor strip and the lower metal plate for electric connections, anti-reflecting coating, and 2 semiconductor layers, one of N type and the other of P type. The basic PV cell can be modeled with single diode model, consists of dependent current source which depends on temperature and solar irradiance, thermal structure modeled by a diode, and there is series resistance and equivalent shunt resistance. The IV relation can be obtained using this equation, where A is the ideality factor, K is the Boltzmann constant, T is temperature. Also, the PV module can be modeled taking into consideration the number of PV cells connected in series and the number of parent branches in the equation. Problem formulation. The main target is to estimate the optimum values of PV module parameters, series resistance, shunt resistance I0 and A, that can satisfy the operating point given in the datasheet. To do this, we select suitable objective function. In our work, the objective function is the difference between IPV minus I estimated plus the difference between fill factors. Fill factor is defined as P at maximum power point over the multiplication of open circuit voltage and the I short circuit. So, IPV is the datasheet module current. I estimated is the estimated value of module current. FF is the PV fill factor, and FF estimated is the estimated value of fill factor. So the main objective, the main target, to estimate these values which can minimize this objective function. Regarding the particle swarm optimization technique, this is a method for optimizing nonlinear function based on the social behavior of flock of birds searching for their food in a social population. Each particle in a swarm represents a solution to the problem. Particles are placed in the search space randomly. All particles have frequency value based on their position and velocities, which direct the flights of particles. In every iteration, each particle is updated by 2 following best values. The first one is the best solution the particle has achieved so far. This is called local best solution. And another best solution called the global best solution, which is the solution obtained so far by any other particle in the flock. After finding the 2 best values, the particles update their velocity and position according to these equations. Particle swarm optimization has simple flow chart. We initialize the parameters randomly, then we evaluate objective function, then we update the velocity and the swarm position, then we should evaluate again the objective function, compute, get local best and global best, and repeat the process for all iterations. Once the all iterations are done, we get the global solution to the problem. Regarding the results, we run the simulation 100 times at standard test condition, and we have obtained best values, worst PSO values, and the average value of these particles for series resistance for the individual cell, series resistance for the overall module, shunt resistance for the individual cell, and shunt resistance for the overall module, I0 and the ideality factors. From these values, we compute, or we predict short circuit, I maximum power point, open circuit voltage, voltage at maximum power point, and power at maximum power point, and the value. We computed these parameters for best obtained VSO parameter, worst obtained VSO parameter, and for the average value obtained after running the system 100 times. Regarding the relation or quick comparison between exact values and best obtained values, we can observe that the absolute value of the percentage error didn't exceed 1.7%, which means that particle swarm optimization is successful to estimate the BVR. While in the case of worst case estimation, the error didn't exceed 5%, which also is satisfactory. These 10 parameters are utilized to plot the IV curve of the PV module. We have 80-watt PV module. We plotted 3 curves. The exact curve from experimental data sheet, experimental data, curve continuous line, which represents the best obtained solution, and the dashed line represents the worst obtained solution. We repeated the curve for power voltage relation. We can observe that PSO give results which is in good agreement with real data. Also, we have studied the system for different values of solar radiance and for different values of temperature. Also, we can observe that the results using particle swarm optimization technique are in good agreement with the real data. We repeated the study again for temperature for different values from 0, 25, 50, and 75%. The family curves of power voltage curve are also obtained. Regarding the percentage of relative error of predicted maximum power at different temperature and at different solar radiance, we have observed that the error didn't exceed 2%. Also, we have studied the convergence speed of the algorithm. The algorithm reached to steady state value or accepted value after nearly 150 iterations, which was around 7 seconds of CPU time. These are the parameters employed in the particle swarm optimization. Total number of iterations 200, number of pairs 100, all parameters of equal distribution 0.5, and the search space for series resistance between 0 and 1 ohm, search space for pair resistance for the individual cell 1 up to 25 ohms, I know between 0 and 1 microampere, and the ideality factor between 0 and 2. So we can say that simple, cheap, and accurate method based on particle swarm optimization technique is proposed to estimate the parameter of PV cell and module at 3 points only without conducting any experimental tests but measurements. The obtained results prove that the validity and the effectiveness of the proposed method to determine the PV model parameters at different operating conditions with good agreement between exact and predicted curves. And finally, the proposed method is fast enough to accelerate the prototyping and design phase of PV system. At the same time, least square nonlinear curve fitting method has failed completely to solve this optimization problem due to the insufficient number of available data of the data sheet. Thank you for your attendance, and really I want to appreciate Dr. Joseph O for his sustained help to send this presentation. Thank you.